Well, my students, we have covered the theory of NMR, the chemical shift, applications of the chemical shift, or the influencing factors of chemical shift, or the factors which influence the chemical shift, and spin-spin interaction or spin-spin coupling, commonly called as SS interaction or SS coupling. Right? Now we can pass on to the interpretation of NMR. That is very important. Interpretation. When you get the NMR spectrum, once you have the NMR spectrum, you have to give consideration to the 5 points to interpret, to get the structure of the compounds. We can discuss one by one. So what are the 5 different points to be noted? You know NMR spectrum. That is an XY plot. NMR spectrum is an XY plot as usual, and this is in the y-axis. You are tabulating the intensity of the emitted radiation, that is the relaxation, that quantity of energy released during the relaxation of proton from the beta position to the alpha position. Okay, and in the x-axis you are plotting the delta or the chemical shift. Which one is taken as the reference material? The reference material is always TMS. The TMS gives a very sharp signal at delta equal to 0. That is the upfield region, and our signals will be seen left to that. So chemical shift varies from 0 to 10 normally. Right? Now the first point we consider, that is the number of the signals. Number of signals. How many signals will be getting left to the signal of TMS? Number of signals, that is equal to number of sets of protons. Number of SCTS, number of sets of protons. And each set, each set contains a definite number of protons which are under similar chemical environment. The protons which are under similar chemical environment, they are called as sets. And each set is denoted by letters A, B, C, D, etc. So A means it contains a set of protons which are under similar chemical environment. B set, another set which are under another chemical environment. Therefore, how many signals will be getting? The number of the signal depends on the number of sets of protons. If there are present only one set of proton, we can expect only one signal. Right? For example, you consider the methane. Methane. How many protons? 4 protons. All the 4 protons, all the 4 hydrogen atoms are under similar chemical environment. Under similar chemical environment. Therefore, all the protons are identical, and hence they belong to the one and the same category, that is A type. So it gives only one signal because it contains only one type of proton, not one proton, one type of proton. Now, you consider the case of CH3, single bond CH3, that is ethane. How many types of protons are here? This is A set. Right? The chemical environment of these 3 protons, they are also similar to this one. So all the 6 protons are under similar chemical environment. So this is also a set. So how many sets of protons are here? There are present only one set of proton. Therefore it gives only one signal. Right. Now you consider CH3, single bond CH2, single bond Cl. See, you consider only the protons, not the carbon, not the halogens, etc. You consider the protons because we are discussing PMR, proton magnetic resonance. See, the 3 protons are alike. Right? These 2 protons are alike. The environment of these 2 protons are different from the environment of the 3 protons because the 2 protons are nearer to chlorine, electron withdrawing chlorine. The electron environment is somewhat different. So the 3 protons are under similar chemical environment. So this becomes A set. So what it becomes? This becomes B set. Right? Therefore there are present 2 sets of protons. And what is the ratio? A is to B. Intensity ratio. A is to B. Signal height. A is to B equal to what? Equal to 3:2. Therefore, signal due to A is composed of 3 protons and signal due to B is made up of 2 protons. Therefore, the number of signal depends on what? Number of signal depends on the number of types of protons. If there are one set of proton, one type of proton, we are getting only one signal. If there are 2 types of proton, 2 sets of protons, we are getting 2 signals. Therefore, number of signal depends on what? Number of sets of protons. Now you see the number of signals given by this compound CH3, CHBr, single bond CH3. That is 2-bromopropane. How many signal it can give? See, this is the middle carbon. The distance, this distance, that is equivalent to the distance of this carbon, and these 2 sets of protons are similar. Am I right? If we are labeling it as A type, this is also A type because they are equidistant from bromine. They are equidistant from bromine. They are having a similar chemical environment. But the chemical environment of this proton is different because it is nearer to the bromine. It is 1 bond away. This proton is 1 bond away. Therefore, if this is A, this also A. But this belongs to what? B set. Am I right? So, how many signals it will give? It will give 2 signals. Why? There are 2 types of protons. So, what is the ratio between A and B? Signal A is composed of 6 protons. 6 protons, and signal B is made of what? Only 1 proton. Therefore, the signal height, intensity means signal height, depends on the number of protons present in that group, present in that set. Therefore, A is to be equal to 6:1. Now see, the number of signals given by this compound C, CH3, 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 CH3. Can you say how many signals it can give? So this is the middle carbon. The distance to this carbon is similar. The distance to this carbon, that is exactly equal to this one. Distance to this carbon from the middle carbon is exactly equal to other 2. Distance to this carbon is exactly similar to other 3. Therefore, all the 4 carbon atoms are equidistant from the central carbon. So all the hydrogens are also equidistant. So they are under similar chemical environment. Am I right? Therefore, if it is A, this also A, this also A, this also A. So it gives only 1 signal because all the hydrogen atoms are under similar chemical environment. Now you consider another example. That is CH3, single bond CH2, single bond OH. How many signals you can expect? You can expect this is A-type proton. The environment of these 2 protons are different from CH3 because it is nearer to oxygen. Therefore, this is B set. Now see the hydrogen present at oxygen, and this is the C set. So it contains 3 types of protons. So it gives 3 signals. So the number of signals depends on what? Number of types of protons. Okay. Now can you say the number of signals given by this one? CH3, single bond O, single bond CH3, an isomer of, a functional isomer of ethanol. How many signals it can give? It is A type. This also A type because these 3 methyl protons, they are equidistant from oxygen. All the hydrogen atoms are under similar chemical environment. So this gives only 1 signal. Right? It's isomer. That is CH3, single bond CH2, single bond OH. It can give 3 signals because there are present 3 sets of protons, but it gives only 1 signal because it contains only 1 type of proton. So the first point to be taken into consideration when you get a spectrum of a compound, that is, you calculate the number of signals available. Number of signals depends on what? Number of signals depends on the number of types of protons. Right? Now, second one is the intensity of the signal. Intensity of the signal. What is signal intensity? Signal intensity is the height of the signal. Right. Signal intensity means signal height. And that signal height depends on what? Signal height depends on the number of contributing protons. If the signal is due to 1 proton, it gives a smaller signal. As the number of the contributing proton increases, signal height increases. So if it is due to one proton, the height of the signal, this will be double the signal of one proton, and this is 3 times as that of first one, because it is the contribution from 3 protons. So as the number of the contributing proton increases, signal intensity or the height of the signal increases. So we can calculate the number of protons available with a carbon by calculating the signal intensity or signal height. So the second point is the intensity of the signal. The first point is the number of signal, second point is the intensity of the signal. Number of signal depends on what? Number of types of protons, and intensity depends on what? Intensity depends on the number of protons, and number of signal depends on the number of types of protons. Number of types of protons, that is number of signals, and the number of protons in a set. That is the actual fact in measuring the intensity. And the third one, that is position of signal. Position of signal. What is meant by position of the signal? I told you that some of the signal will be nearer to the TMS, some signal will be away from the TMS. And depending upon the chemical environment or shielding and de-shielding, signal position may vary. Some will be nearer to the TMS with a lower value of chemical shift. Some will be away from the TMS with a larger value of the chemical shift. Right? So as shielding increases, shielding of the proton increases, chemical shift value decreases, and hence such signal will be seen nearer to the TMS. So third one is the position of the signal. First one is the number of signal. Number of signal depends on what? Number of types of protons. Number 2, intensity of the signal. That is signal height. Depends on what? Depends on the number of contributing protons. Larger the number of contributing proton, more will be the signal height, or larger will be the signal intensity. And the third one is the position of the signal. Position of the signal depends on what? Chemical shift. Or chemical shift depends on what? Chemical shift depends on shielding and de-shielding. Shielded protons can be seen nearer to the TMS with a lower value of chemical shift. Right? So suppose it is 1 and the chemical shift is 1 minus 0 equal to 1 ppm. And some signal will be away. Suppose the value is 5. 5 minus 0 equal to 5 ppm. That is the chemical shift. So this is shielded, more shielded, this is less shielded. More shielded protons will be seen nearer to the TMS. As shielding decreases, the signal position will be moving more and more towards the left. So the position of the signal depends on the shielding and de-shielding. And the fourth point is the multiplicity. The fourth point is multiplicity. What is multiplicity? Subdivision of the signal into multiplet. Subdivision of the signal into multiplet. And the multiplicity depends on what? Multiplicity of a signal. How many sub-signals are possible for this signal? And how it will be splitted further under high resolution? That depends on what? Number of the neighboring protons. So number of the neighboring proton decides the number of multiplets available with a signal. So multiplicity depends on the number of the neighboring protons n. So signal due to a set of proton, that will be changing into a multiplet due to the interaction with the neighboring protons, and the signal will be splitted into n plus 1. What is n? N is the number of the neighboring protons. And what is the intensity of the signal? Intensity of the subsignal. Intensity can be read from the Pascal's triangle or from the coefficient of expansion r plus 1 raised to n. In that way we can calculate the multiplicity of a signal, right? And the last one is exchangeability. Fifth one is exchangeability. Exchangeability, that is the easy way to shift from the position from the group. For example, hydrogen connected to oxygen, hydrogen connected to halogens, and hydrogen connected to nitrogen. These oxygen, halogens, nitrogen, etc., they are electronegative, and this hydrogen can be easily transferred. This hydrogen can be easily exchanged right? Acidic hydrogen, so it denotes the presence of acidic hydrogen, and exchangeability denotes the presence of acidic hydrogen. Acidic hydrogen means hydrogen connected to a more electronegative atom like oxygen, halogen, nitrogen, etc. Right? If a compound contains an exchangeable hydrogen, there will be a lesser number of signals because that hydrogen will be moved away from the group. So sometimes it will not give a signal. Whether a compound contains acidic hydrogen or not, we can determine the presence of acidic hydrogen from this exchangeability. Right? So you need to give prime importance only to the 4 different points. The fifth one is less important as far as you people are concerned. One is the number of signals, second one is the intensity of the signal, third one is the position of signal, fourth one is the multiplicity. I shall summarize. These are the different points to be observed while interpreting an NMR spectrum. Once again, number of signal, that represents what? Number of types of protons. Number 2, that is the intensity of the signal. Intensity depends on what? Number of contributing protons. This is the number of sets of protons, and in each set, how many protons are contributing? That is the intensity. That decides the intensity. And the third one is the position. Position depends on what? Shielding or deshielding. Shielded protons can be seen nearer to the TMS reference, and deshielded protons can be seen in the downfield away from TMS. So the position of the signal, that depends on the chemical environment or the shielding or deshielding of a proton by the electron. And the multiplicity, that is very important. Multiplicity of a signal. A signal is due to a set of proton that will be splitted further under high resolution due to the presence of neighboring proton. You look upon the number of the neighboring protons which are present on the left, right, top, bottom, etc. There present the neighboring protons, and due to the neighboring group interaction, neighboring proton interaction, that is known as spin-spin interaction, each signal will be splitted. So what is spin-spin interaction? It is the interaction between the spin magnetic moment of the neighboring protons with the magnetic moment of the applied field. Right? Due to the spin-spin interaction, each signal will be splitted. And the last point is the exchangeability. It gives some information regarding the presence of acidic hydrogen present in a compound. Right? Then I shall give more examples to make it right or to get through. Then only you can understand.